Dear students, today we will talk about nuclear reactions, nuclear reactions and their cross section. Now, simply that the reactions which involve nuclear particles like neutrons, protons, etc. are called nuclear reactions, but you have to lay an emphasis on what does cross section mean as far as your understanding is concerned, right? Generally, we say that cross section is the effective area of an interaction, effective area in which an interaction took place, right? This is the superficial meaning, a correct but although incomplete and superficial meaning of cross section. It is the effective area within which an interaction takes place, right? For example, if you have two balls and you hit them against each other, there is a particular area within which they have interacted, and this area is called as cross section. Therefore, of course, this cross section has the units of area, and we measure the cross section in terms of centimeter square, etc. Now, there are two things in this case. One is that if the two bodies physically collide, that is called as collision. And then there can be two like similar charged particles, like a positive particle and another positive particle. They cannot come together to physically collide, but they can scatter at a certain distance on account of force of repulsion, right? So that's called as scattering. So scattering is also an interaction. Scattering is an interaction, collision is an interaction. Here the bodies physically collide, here they don't. They interact through their fields, the electric fields, the force of repulsion, right? But even then there is an effective area within which they have interacted, and that area is the cross section. Again, that cross section is measured in terms of centimeter square, right? Now, in case of nuclear reactions, you have to understand what this cross section should actually mean, right? In case of nuclear particles like neutrons, protons, they are so small that you cannot actually realize a situation or imagine a situation wherein you can throw a neutron on a neutron. See, you can throw a stone on a stone, a pebble on a pebble, a ball on a ball, a ball on a wall, right? But imagine a situation wherein you have to throw a minute microscopic elementary particle or another particle. Do you think we can even imagine a situation wherein we can hit a neutron with another proton, an electron with a proton? No. This situation is not imaginable. So how can we define cross section in these cases? We say that we shoot a lot of them, by them I mean the elementary particles, the nuclear particles. We shoot a lot of them in some common general area, in some common general area, and then we see what is the output. For example, there is an instant particle A plus B, they interact, they scatter, they collide, they give some resultant particle C plus D, right? So once we shoot a lot of them in some common general area, we see what is the output of the particles. And then we see how many number of particles or the flux of particles that we have obtained corresponding to a given unit of area. In this way, we find the cross section in case of particles of elementary nature, of nuclear nature, right? So cross section is defined in an alternative sophisticated manner once we talk in terms of nuclear reactions, because we know that particles cannot physically collide. They are so small we cannot aim throwing one particle at another, right? So once if you understand this, then we can proceed to derivation of this cross section.